Let's create Rust core and Python app, both project directories too. All right. And now we should have, yeah, Rust app and Rust core. So I'll try, speaking less for this project because, well, I am also curious and I also want to see where we can go with this. CD Rust, well, if you're a beginner, you should know CD is change directory. I don't want to speak right now, but I should actually. We are initializing a cargo, which is, Rust. Uh, but we are saying that we will be creating library, not binary. So this will be a library. We know what is the difference between library and binary. We know that a bit. So cargo terminal has been initiated. Let's see what is there in the cargo terminal. Ah, exactly something like this. Now dependencies are not there. Oh, C becomes something like this. Did it? Let me see. Yeah, it is exactly something like this. Whereas we have cargo.toml and in src we have lib.rs. Nice. So, what is the main thing that we are trying to achieve using this project? It is to see how we can combine both Python and Rust. Like I have never in my life combined two languages together for just one single task. Now I am doing that. Like I've used libraries like NumPy and all that, which combines C and Python, but never have I made my own thing, my own APIs, my own libraries to be used using some other sort of app or language. Now stage 3 is to edit cargo.toml. Well, I think for editing part, we shall do it without any sort of mistake. So this is not a experimentation. This is just sort of implementation that we are trying to see if possible or not. So package is still there. Dependencies, well, we'll delete these. All right. So now it becomes what is it? Where did I invoke this manifest format? All right. So that I can, you know, check whether both of them are same. Well, they should be, except for the addition. Doesn't matter. All right. We'll save it. Quit it. Now stage 4 is that it's saying create Rust files, which is filter.rs and FFT. So we'll touch filters.rs and FFT.rs inside src first of all. Src, we'll say touch filters.rs. Oh, filters.rs. Let's see if there is S in filters. Exactly, filters.rs. No typo. And then fft.rs. All right. Shit. Well, things happened. Exactly the same tree that the GPT has been expecting from us. Same tree. Now in stage 5, we have to write the filter.rs. So filter.rs first of all has pio3 and some prelude. Pio3 is a library, I guess. We are using that. And then we are creating a pipe function which is EWMA. And then we are calculating EWMA, and then we are passing or giving out the result. So let's do that. src filters.rs. We are pasting it. If you want to see the code, well, here it is. We're creating a py function, so I guess we can access EWMA from Python. We are using PYO3 so that we can make a library that is compatible with Python. And in function EWMA, we are passing out signal, which is of type vector F64, alpha, which is F64. So this is just a float number, whereas this is a vector containing multiple float numbers. And the return, which is the result, will be of type vector F64. So this will be a pointer or vector. Now we have a mutable result, which is, well, getting the signal's length, this vector's length. And then we have a mutable previous, pref, which is, well, initialized at signal 0. And then we are saying result dot push, whatever that result is, push it to prev, which is this. And that's what we are trying to do. And then we are taking that previous in the loop for a reference of x. What is x? I don't see x. So x is in this whatever the signal length may be, or the last thing it may be. So for all these x, like starting from 0, 1, or whatever, signal 1, what is there in signal 1? I don't know. But we are multiplying it with alpha, which is a number that pass for. And then we are adding it sort of 1 minus alpha, the number we are passing, multiplying it with previous, and then we are pushing previous again so that previous gets updated from signal 0 to something else, and then we are passing the result. I think it's clear. I think it is. So let's go to, well, stage 6, which is, create fft.rs. Copy it. Well, why am I not coding it? Because I don't want to experiment with my typos, because I know I will make some typos and I'll know that I have to debug it. I just want to quickly, sort of see the integration between Rust and Python. That's the result I want. Well, PyO3 prelude, and then Rust FFT, which is FFT planner, and Rust FFT. Oh, so there are libraries like Rust FFT and PyO3 is there, we know. But Rust FFT has FFT planner, num complex. From there, we want complex. I don't know what it is doing, but all right, all right. Let's move on. And it says modify the lib.rs, replace the entire file with this. So there must be something in lib.rs first of all. We should replace everything with the given code. Exactly, there is a test. So let's open up a new line, paste all the core, which is nothing but Wi-Fi core is a function, and then wrap function of EWMA and FFT power. So we'll access in Python something like Wi-Fi core dot EWMA or FFT dot power in Python, I guess. That's my guess. Like, best of my guess. So how many lines do I want to delete? I want to delete something like 13 lines. So is it similar? It is. We'll save it and exit. Now stage 8 is to, compile Rust module for Python. Now I think it will sort of install things too, like all these dependencies and all. So we have to say mature in develop release, and it might take a bit more time. Mature in command is not found. Well, did it give us any sort of instruction? Mature in is there, is not. How should I install it? Hello. Yeah. So it is. So we will try to create or install all these well libraries. So how to create virtual environment in Arch? Well, we say Python, well, free, then dash m, then venv is there, and we should name it exactly venv. We don't want to think about naming and all that. It'll create. We can create my venv using changing the last one to my venv, something like that. My virtual environment, and it will take some time. Well, it has taken some time. Unless we have venv. How to activate this venv? We'll go to source and we say venv. Inside that we have bin. We have activate. Well, we activated. Now we see there is a venv activated. Now we'll paste all these pip install maturin, numpy, matplotlib, scipy, all that. It might take some time. So let's wait and see. Till then, let's see. We were at our compile stage. We were sort of compiling it. Maturin develop release. Inside Rust core folder, run this. This will compile Rust and install a Python module called Wi-Fi core into your Python environment. So it says into your Python environment. It means our Python environment should have been activated to do this. Yeah. I think we know where the compilation error might have came from. And then we'll create a stage 9 where we'll create Python test core.py, and let's write it first of all, uh, from here. Well, how about, we wait for a few minutes. But let's see the whole idea. After writing Python, which is testcore.py, we'll run it using Python only. So Python and Python app, then testcore.py. That's how we run a Python app. And you should see a signal plot, filtered signal, FFT spectrum. Now this confirms that Rust and signal processing plus Python visualization works. After this, next stage will be to build a real RSSI detector. So this is not a real, this is just a, demo sort of that Python and Rust works together. That's well really what I want to know. As for SSI acquisition and filtering and all that. Well, important, but not much because we are just learning how to use both of them together. As someone is very interested in this project, well, they can go with their own sort of questions where they just use Python because it's very easy to prototype the apps on. All right, so I'll not wait now. So I'll open up another terminal where I'll first of all go into my directory, and then over here I'll open up Vim named as testcore.py. No typo, I don't think so. Beside that, we have to paste this. Well, don't run it. We paste this and looks great. Save it, get out of it. And now we shall see part 3 somewhat like this. Well, why is the tree something like this? Because we are installing all these libraries. So yeah, that's what to be expected. Well, it is first of all downloaded NumPy, then Matplotlib. Now it's downloading SciPy. I've never used Matplotlib, honestly. As for SciPy, well, that too. As for Maturin, well, it is very new to me. It is sounding new to me, so. Once you finish stage 0 to 11, what is the 11th stage? Ah, running it. But I have not completed the stage where I compile it. I did not complete stage 8 and then stage 11. So 8 and 11. How about we closing this terminal? Only one terminal should be enough. And what you are seeing over here is, well, this is my terminal. Whenever I shorten it, it somehow, renders the earlier one useless and then starts making a new one. So Matplotlib has been downloaded, which is 9.8 MB, you know, and this has been sort of stuck there. It's useless, but it's still stuck. It is, well, some rendering problem that I can't figure out. I'm using Arch Linux, so yeah, obviously we have to figure out everything. But still, it's workable with. You can work around with this. That's why I mostly don't use two terminals together in one workspace. If I have to use two terminal, I'll go to a newer workspace. I'll open up a terminal and it works fine. But two together, not so much. Well, since I'm live streaming and all that, that's why I think the internet is very slow. So if you're watching this, well, just try skipping it. Why are we downloading a font tools? I don't know if it is somehow, related libraries, dependent libraries or something like that. But I don't think we said it download font tools. I just copied and pasted this, which had three things, I guess. No, four, which is Maturin, downloaded, NumPy, downloaded, Matplotlib, downloaded, nice SciPy is also downloaded. SciPy is downloaded. Where is it? SciPy is downloaded, 35.2 MBs. Now we are downloading some Contour by Cycler, font tools, Kiwi solver. Well, do we need it really? I have not said it would be downloaded, but it is. And it says Maturin is required to compile Rust into Python modules. So, yeah. Dependencies are PyO3, Rust FFT, ND array, which is sort of NumPy's array, but Rust format. This is not a NumPy library, but it does exactly what NumPy does to Python. But ND array is very native to Rust. Rayon, I don't know what Rayon does. Matter and develop, release. We'll just get downloaded. Now it's downloading Pillow. I've heard Pillow. Pillow is used for, I guess, PI have used for image generation. Pillow. Six bypassing Pillow. Oh, so now it's really installing it on system. All right. So it's going to end soon. Ah, so everything has been downloaded. Uh, let's check it again. Now it should run very quickly. It ran. As for pip install upgrade pip, we'll do that, but not exactly here. We'll do that in our fourth workspace as I've already said. Pip install upgrade pip. Ah, that doesn't work. I guess we should do something like sudo pacman.s and python python pip, isn't it? Pc pip. Let's check it. Python pip, exactly. So let's do this. Well, now it has installed 26th version. All right. Now, if anybody would create a new environment, they'll get a updated Python virtual environment. Now, since our tree is ready, how about we just do -l tree -l v of 2. So we have Python app, we have Rust core, uh, SRC has something, and then we have, well, virtual environment. How about making it 3 so that we can see some things? So we have Python app, Rust has SRC, which has FFT filters and lib. As for target, we don't want to see target. VENV, we don't want to see VENV also. So now we should go into Rust, which is our step 8. We have to complete our step 8, which is this. We have to run this Maturin develop release, and this will compile a Wi-Fi core, sort of. Why? Because, well, our name of this library is Wi-Fi core. All right. So if I run this, yeah, now it's creating. Now this will also fetch these libraries and dependencies. We see our first error that failed to build a PIO3 FFI and exit successfully, which is all right. STD out is if environment changes PIO3 cross and all that. Standard error. The configured Python interpreter version is 3.14 is newer than PIO3 maximum support, which is 3.12. Oh shit. So I think we have to somehow, go to Python 3.12 version. Do we have a Python 3.12? Python 3.12. Do we have this? We don't have 3.12. How about sudo o? So in step 8, we faced sort of this error. So we'll say step 8 has this error, and we won't specify which error, but I think it is because of Python, which is my latest Python 3.14, and go. So this is the sort of error that you have to go through when you are on the latest sort of environment and Pythons. See, I used Python 3.14 instead of 3.12, and PyO3 just gave out. See, exactly, it found out that Arch Linux recently moved to Python 3.14, which breaks the older PyO3 version. There are two solutions. Correct long-term one. All right. So it says upgrade PyO3 version. We will upgrade PyO3 version that supports Python 3.14. So we'll open up the cargo.toml. Inside that, we'll replace this dependency exactly to this, and we'll save it. So let's go. That's why we should always version lock our, oh, there is a version lock, but dependencies a little bit. Let's clear it out. Let's go to cargo.toml and in dependencies. So we have a Rayon ND array, Rust FFT, PyO3. So all these 4 things are there. Just a version changed from 2.0 to 0.28. All right. So we'll delete these. And we'll close it. So we did it. Step 2 is, well, we have to clean everything by saying cargo clean. Yeah, it cleaned the, target file. So it'll have to compile it again. This removes the old incompatible compile artifact. Now we run this mature in develop release again. Let's clean it for a very dramatic effect. Let's see. Yeah. Well, I love seeing projects getting compiled. Hmm. Found 3 bindings, no errors. Good for us. After creating all the C Pythons, we have to, you know, sort of verify if whether Python can implement our Wi-Fi core library that we have created just now. All right. And if it does, we print module has been loaded. Nothing like that. Then we exit from it and well, I checked out because of this error. Exactly. What should happen next? Once Matter develop works, then run our test code for .py. That confirms Python visualization and Rust signal processing. After this, next stage will be to build real. So this is the real command. IW is sort of, network configuration. From dev, we go to WLAN 0, which is sort of, our Wi-Fi device, if it is there. Sometimes it's 1, it's sometimes 2. So WLAN 0, WLAN 1. We'll check it out. We'll press tab so that it enters it again automatically. Damn. Shit. We get another error, which is this. It says, so I think this is because of all the copy paste functions that we did. So there are some errors in the function. So let's go paste it out. So I think now this will have to, edit our libraries or some other files. We'll have to do this. This will take more of a time. See, now it says edit our lib.rs. Open this file, replace entire code with this. So our fix step 1 is like this. We'll create a new lib.rs. Let's clear it out. First of all, using cat command, we'll do this. All right. We'll go to src, lib.rs, whatever is there. I don't care. We'll just print a new one, give it a line, control D. Now, yeah, it's done. All right. So this is a write sort of function, like we use write in a Python, no? And if we wanted to use append, then we would have used two sort of these arrows, but we'll just write it out from new. Now it says rebuild, so we have to again cargo clean, install everything. Shit. Now it seems so that I don't like just compiling. I compile successfully. If it's failure in compiling, well, I hate it. Absolutely hate it. I think so that everybody else also hate it. It's, that's what happened. It is now compiling Rust core. I think last step. Just compile it. Well, if anybody wants to know, my CPU is running wild, like 97, 98, 100%. Yeah. Why? Because I'm well live streaming as well as, compiling this. And I am on low end. And well, it has compiled. Good for us. Since it has compiled, we'll have to verify by importing it. Oh, not this. So we'll just say Python and we'll try importing it over here and we'll press enter. And yes, we do import it. If we can import it, how about not just doing this? Oh, quit or exit, isn't it? I have to say exit. Yeah. Uh, I have to run the Python. Let's go and copy it out. Hey, how about just writing it out? Python. Oh, first of all, CD. Now let's run python Python app and testco.py. Let's see. So this is another error. So it sort of ran and gave us a warning that figure canvas argument is non-interactive and thus cannot be shown. So plot plt show cannot run successfully, but I think this has worked out. Now we have to just create. Now it's explaining like why this error happened. So there was old API which was using module and this, which is mpy module, and new API uses this like, well, I don't know, but something like this. And this ensures the memory safety with Python's GC. Well, first of all, let's do this. So I think this was just a demo, so therefore we did not use an interactive sort of canvas argument. So that's why this could have happened. But let's see what our GPT has to tell us. So good, the Rust module compiled correctly. The warning you see is not a code problem. I know it is a matplotlib backend issue. So the environment you're using, the AGG backend, which cannot open window. This usually happens when running inside virtual environment without GUI backend. Matplotlib default backend is AGG. We just need to switch the backend. So install GUI backend. Okay. So we have to install few things again. TK is for Tickinter, I guess. Tickinter or something like that. Oh shit. First of all, just clear it out. And again, it's installed. So there will be no locking issues. TK is Tickinter, which is used for, creating interactive Python sort of apps. That's all I know about TK. And I've created, buttons and all that using Tickinter. It was very earlier on. Then I moved on to web development and then integrated that with Python. So then, creating beautiful React apps and the backend was running on Python. So I didn't use Tickinter very much for interactivity. So we installed it. Now we have to reinstall our matplotlib. Let's go and do that too. Now the another fix is, just give it an argument to use tk agg instead of just agg. So let's copy this and we'll paste it using cat argument. That's lovely. Not append, like this is for append, this is for write. Now we just have to run Python and whatever is this. We run it and we see some signals, some outputs. All right. And my CPU is spinning up. Well, I want to sort of screenshot this and give it to a GPT. I just have to say, there is the result. RESULT. All right. Then let's first of all sort of close this app. That's how we end it. And the next thing that I want to do is run this command iwdev. Well, I also want to see, am I using volen 1 or volen 0? L IW command is not on. Damn. Do I have to install IW? Shit. Why I am very familiar with IW? Because I've installed it previously. And I guess in, while installing the while installing the Arch, you just get IW to connect your Wi-Fi. So I've used IW, but somehow after installing sort of Arch, we get a network manager and which is something like NLW, something like that. And network manager, so NMCLI. All right, NMCLI. Yeah, so this is it. You want to see these are all the things. NMApplet. This is NMApplet, which is I'm using it. Sort of connect and MCLI. This is the thing that I install after Arch so that I can manage my network quite easily. IW was always there. If it is not, we can just install it. That's what I thought. Shit. Now this is a rendering issue in my terminal. So let's type it out. Sudo pacman-s and what is it? IW, no? Now again I have to say IW and then I have to say dev and there is no tab completion, so well, that's bad. But just this much. Interface is WLAN 0. Good. Now we have to run iwdev WLAN 0 link, something like that. So we'll do that. iwdev and WLAN 0. Yeah, there's no tab completion. 0 and then link. Well, expected output is something like this. Exactly it is. So the important line signal minus 47 dBm. Where is that? Minus 38. So see, this is signal. So we'll be using this signal. Now it says the project 3 will now expand. So Python app will expand now. So create the files, we will, but before that, oh shit. So it gives me the code for RSSI reader. Well, remember that because now we have test core and RSSI reader as for liveplot.py. We don't have that yet. And as soon as we run this RSSI.reader, we should get RSSI of minus 45, 46, something like that. So how about we do that? How can we do this? Let's copy this. We'll use cat, I guess. Or should I use vim? Cat is there. So we'll say I am going to write a new file. Shit. ls rm import. We removed it. ls python testcode.py. About I define something like Python app. Inside that, instead of testcode.py, we want RSSI reader.py. RSSI reader. READER dot py. And now I have to paste this. Let's paste it. Now we have to run it. Clear it. And now we have to run it. Python Python and RSSI dot reader. No such devices. So let's see first of all. Well, clear first of all, and then let's see what sort of device are we talking about. Did we write something else instead of WLAN 0? So we'll search for that. Yeah, interface is not this. Change this. So it says change this. So we'll change it to WLAN 0. Did it suggest me? WLAN. I think it suggested me. I'll take it. Then everything works. I don't have to change anything. Now we'll try running. Where was it? Where was the Python? This. We have RSI of. All right. We'll close this. And we'll sort of copy it. And we'll paste this result as well. Excellent. Everything is behaving exactly as expected. So output is shown good. Those sudden drops, like, there's no movement, but still there are sudden drops. So yeah, something like minus 51. Sometimes, yeah, so there are some disturbance, but these definitely are not human motions. Let me clarify that. Stage 3 is something like real-time Wi-Fi motion detector. So we'll create a new program that, first of all, RSSI stream, it takes that and make a rolling buffer, then Rust EWMA filters, uses now Rust library that we have created, and then creates a variance motion score and gives us a live graph. So all right. So I'll try moving, but first of all, let's create it. Project tree after this step. So we have to create motion monitor.py. Yeah, it says create motion monitor.py. Let's copy this. See, I'm copying it. All right, and let's do using cat because I love cat. And now just paste this. Paste it. Give it a new line. Exit, and it has been saved. Now I have to run this from project root. Well, I am at project root, and now I have to run this. I'll run it. Well, it runs and screenshot it. Yeah, now I'm moving back and forth. There's a lot of movement, and now I'm sitting still. Yeah. So if I sit still, well, this is quite interesting now. This is quite interesting. As for this motion score, I don't know what it's doing. How about I go for a walk? Well, still doesn't capture much, but we are happy because we have integrated our Rust and Python app. So we are very happy. Now let's interfere with it. We have interfered, and now just paste observation. Why this works? There's router, there's wall, but there's not much of a router. I am using my well phone as a router. So yeah, signal, well, it was just, so it says next stage, much more powerful. We'll add Kalman filter, Butterworth filter, multi-feature anomaly detection, FFT breathing detector, real-time radar style plot. So breathing detection, not yet. Well, presence detection is very rough. Room activity spike, it is there. Human movement, I was moving. So yeah, motion score is 1.45, which means the system is detecting by variations. You are using your phone hotspot as router is completely fine for this experiment. In fact, it can sometimes produce a stronger signal variation, which helps detection. However, we should make two improvements now because RSSI from a hotspot is noisy. Add real motion threshold and show the motion events clearly. Stage 4 is, well, we have to modify this file. And that's why I use cat, because now I can just, save and cat this file exactly same. And now we'll just paste the improved version, which is this. Seems long. And we'll have to run this again. We'll paste it. We'll save it. We'll clear it. And now we'll run it because it says so. Motion detected, motion detected. Oh, well, I am not moving now. Shit. Let's run again and we'll take a screenshot of it. And that's it. Well, take a screenshot. Yeah, now I'm not moving, so no motion has been detected. That's good. That's good. Now suddenly it is detecting motion. I don't know how, but suddenly it is too much. So let's close it. Let's paste it. Sometimes it's working, sometimes it's having too much noise to even work. So it is something like, filters, more filters, some motion analysis, and we'll use multi-threaded processing for, calculation in Rust. Then radar style visualization, a circular motion heat map. Well, now this is getting interesting, but as soon as it, well, times is up, I'll just remove this sort of project. Uh, One quick question. Your signal range is 32 minus 45 dBm. That means your phone is very close to the laptop. Yeah, exactly. And for better motion detection, try something like distance between phone and laptop of 3 to 5 meters. All right. I'll give it a... So now it has a difference of 1 meter. This increases the multipath reflection, making movement easier to detect. Okay. If you'd like the next step, you can turn something much closer to the story. All right. So well, if anyone is seeing me, tell me if this project is near completion. Is it good? Is it bad? What happens next? Well, my screenshot shows that there's a motion detected, and the graph motion score is 0.80, but your threshold is 2.0. So if the threshold gets to 2.0, it says motion detected, but if it is less than 2.0, it says no motion detected, something like that. And fixes that print motion only when changed state changes. I don't want to do this. But before that, it has given us a task. Well, we have to replace a while loop with this version. Let's see. Now we have to go Python app. What was it? Motion detector, isn't it? Inside that we have a while loop. Which one? This is also a while loop. So this one. Yeah, exactly this one. So before editing or deleting it, we'll first of all insert some dashes and we'll make those dashes as comments. We'll get to the end. We'll create some more dashes and we'll paste it. A new while loop. So last motion state is false. Well, a new variable. And then we use something like same thing. While true, do these stuff. I think we can either delete these or what should we do? Should we delete these? 20. Oh, EPJ. Somewhere more, so 14 DJ and some more like 5 DJ. Let's do 4 DJ. Just do a DD for this. Save it. Clear everything. And we have changed a loop. So let's run Python again. So no motion has been detected because I am not moving. I am moving now. Yeah, so motion has been detected. Now back again, I'm not moving. Will it go back to normal? It is not. Well, trying to go back to normal. So yeah, it is there. But it's giving us some spikes, more spikes. I think we'll conclude this project for now. It shows that motion has stopped. Let's take the screenshot. Motion has stopped. All right, so even if there is a small motion like speaking or breathing, or even, moving a mouse, it somehow changes this motion scope. So like I am not moving my mouse anything. And now I am. So my body is moving now. So it is increasing. See, it gets increased. So I think it's working, but with a bit of lag. But this much of lag is, all right. Now motion has stopped, obviously. Yeah, I sort of moved my hand to explain, obviously, but yeah. Did I breathe too quickly? Like, what is happening? It is interesting. So let's take a screenshot and paste it. And just say yes. So whatever it's next, it'll give us the instruction. As for now, well, my CPU usage is good enough. What is this home? I see some home. Some tinkering things. Next upgrade would be Butterworth filter and Kalman filter. Well, important thing to note over here is I am not even coding. I'm just trying to understand. So, well, I think GPT is getting smarter and smarter. So it's better to learn from GPT rather than just extracting its value. So my pipeline is now stable. Phone's hotspot is there. RSSI sampling we are doing. We are using Rust EWMA filters that we have created. We have a variance motion detector and then state change events. Well, should I or should I not publish this project as my project, or should I just make it like a vibe coded project? What should I do? Well, stage 5 is add Butterworth noise filters. Well, first of all, we can improve this as much as we can, then we'll publish it. Right now, you only use something like EWMA smoothing, but a Butterworth low pass filter removes the noise much better. So it tells me the pipeline will become something like RSSI, that is from Python. We'll go to RSSI is from Python, no? LS Python. Uh, RSSI reader. So from Python, it goes to Butterworth filter. Then it goes to Rust EWMA instead of just directly going. File structure will differ. No new files needed. We only modify monitor motion monitor.py. It says add this thing. Step 2 is add a filter. And step 3 is to modify the processing pipeline. Replace this part, which is filtered Wi-Fi core EWMA, with this part. Good. So since it's telling us to change things, we will. So let's get started from step 1, and we'll use Vim for this, not cat, Vim. So let's do Vim, Python, and then motion monitor, not py. It says print this. So I think, yeah, exactly same. Step 2 is to add a filter function. So this is a filter function. So I think I'll define this filter function sort of at the top or over here. Let's do it over here. Let's create the filter function, give it some space. Oh, it's already in insert mode. Low pass filter. This is a filter. Give it a bit more space. Then we have to modify this filter. So let's see, where is it? Yeah, over here. So we have to modify this. Yeah, it's only there. So we have to modify this. Yeah, I don't see filtered anywhere else. So let's GCC it. Oh, shit. GCC. Let's get a new line. And we'll add this line. There's some indentation problem, so we'll indent it properly. Now there's no indentation problem. We'll close it. Final signal pipeline is, now the code does something like raw RSSI goes to Butterworth filter, then Rust EWMA filters, then variance motion detection. This will reduce false detection by 50 to 70%. Run again and see this. For your build, next upgrade. Should we do this? Should we take this new upgrade? So it says make the Butterworth filter into Rust. So we'll do that. We'll do that. Before that, let's see if our monitor not by works or not. See if it works. It works. So nothing has much changed. I'm not moving. I am moving. I was moving actually. And now back again, I'm not moving. So now it's detecting quite, well, I would say, accurately. Now let's close it.